Chapter 3, Number 51. A police car travels at 38 meters per second due east while in pursuit of a vehicle that is traveling 33.5 meters per second due east. What is the velocity of the vehicle relative to the police car? And then what is the velocity of the police car relative to the vehicle? Certainly not a bad idea to do at least a little sketch. So we'll do like an overhead sketch where we have police car. And the police car is moving with some velocity. And honestly, the problem actually kind of goofs. It's clearly a relative motion velocity, and yet they don't tell you what the speeds given are relative to. Pretty clearly, they're relative to the ground. So we'll say the police relative to the ground as our velocity for that guy. And then we know that somewhere else there is the other car, which is running away. The police car is in pursuit, so we'll assume that's behind. That wasn't explicitly stated, but that seems reasonable. And this one is, we'll say, the crooks relative to the ground. And what we're asked for is, what is the relative velocity of the crooks to the police car? So what we're looking for is the relative velocity of the crooks to the police car, which the relative velocity formula tells us is the velocity of the crooks relative to the ground plus the velocity of the ground relative to the police. That's a little weird, right? But what we end up saying here is we're saying that what we know is that the ground is going past the police car oppositely. So that's the same as saying, right, we have the crooks relative to the ground, and then we're adding negative the police relative to the ground. Because if the police are moving due east, then they see the ground moving due west at the same speed. So relative to them, it has the opposite velocity. And then we can actually just sort of plug in. And we can say, well, the velocity of the crooks relative to the ground was 33.5 meters per second in what we'll call the x-hat direction. And the velocity of the police car was 38 meters per second in the same x-hat direction. And so we end up with 4.5, right? Minus 4.5 meters per second in the x-hat direction. Or if you want, it's 4.5 meters per second in the minus x-hat direction. So the police car sees the other car approaching at a relatively slow 4.5 meters per second. That if you take the police officers as the reference frame, the other car is drifting westward. It's drifting towards them. And it's already east of them, so that must be drifting westward. You could do the same rigmarole with the police car relative to the other car, but in fact, I'm going to shortcut that as well and say, well, we can always switch the reference frame, so police car relative to the crooks, right? That is what part B is, and that's always the same. We can switch the reference frame by switching the sign. So we get minus 4.5 in the minus x-hat, or 4.5 meters per second in the x-hat. So if the crooks are at rest, if they're saying what's happening relative to us, they see the police car west of them, but catching up, which means it must be drifting eastward, which is what we see here. And it's drifting at, again, the relatively slow 4.5 meters per second. So that's a lot of formalism for a thing you probably could have reasoned through on your own intuitively, but it's kind of nice to see that it works out.